I have the pleasure of leading our global blockchain team, and I want to thank that team. Many of them are in the audience, many of them will be online. Just want to thank them for their hard work, their dedication, their enthusiasm for blockchain. There wouldn't be much to talk about today if it wasn't for the team, so I just want to recognize them. But we do have a lot to say, so let's get to it. Today we'll talk about what is blockchain, we'll talk about blockchain for the enterprise, and then we'll talk about how HPE can help. So what is blockchain? So many people feel we're at the same point today with blockchain and the exchange of value as we were in the early 1990s with the internet and the exchange of information. And in 1991, I was the CIO for a management consulting company, and I was responsible for supporting our consultants as they traveled the world. And 1991 was also a very important time in the evolution of the internet. In 1991, the first website was put online, hence the creation of the World Wide Web. But it was also an important time for my company, because that was when I walked into my boss's office, Bob, and I asked him for money for this brand new technology called email. I said, Bob, you want to send a message to the CEO, Jim, upstairs? All you do is type it up, you press a button, he gets it instantly. And Bob turned to me and he says, well, what do I need that for? I just tell Marie what I want to tell Bob. She types it up, she walks it upstairs, and he has it. And I said, you know, he was right. I said, well, I'm the CIO, another use case. What about if you want to communicate with the partners overseas? Well, you know what? I tell Marie, she puts it in the fax machine, and off it goes. So Bob was right. And we had a difficult time getting our heads around the fact that if we remove the intermediaries from the exchange of value, the intermediaries from the exchange of information, FedEx, the Postal Service, magazine subscriptions, if we remove those from the chain of communication, we could not conceive that our ability to communicate would actually improve. Now, it's no surprise to us in 2017 that it did improve, because pretty soon our consultants were traveling around the world. Bob gave us the money, even though I couldn't explain too well. We installed email. They were able to communicate with each other, with their customers, with anyone else, more efficiently and easily than ever. And there was no way that we could conceive of Google, of Facebook, of Twitter. Today, if you want to communicate with one person or 1,000 or 1,000,000, you just do it. There are no intermediaries. But how do you pay for a taxicab? Well, it's a three-step process. If you use your credit card, there's authorization where you submit your card. It goes from the cardholder to the merchant, to the acquirer, to the credit card network, to the issuing bank who issues a payment authorization code. Then you have step 2, which is 5 steps, where that payment authorization code goes back to the credit card network, to the acquirer, to the merchant, who gives you a receipt. You leave the cab, the transaction, and all the other transactions are stored in that point of sale device to be transmitted at some time in the future. That time in the future is called clearing and settlement, and what happens, the merchant transmits all the transactions back through the acquirer to the credit card network, who has to go through each one of them and decide which bank those credit card transactions should be sent to. They send it to the bank, who does a number of things. They issue the funds, they charge the fees, and it goes back through the credit card network to acquire to the merchant, and finally the bank then posts the transactions to your credit card account, and you pay the bill at some time in the future. Simple. What does all that add up to? 16 steps, 6+ parties, 7 days, and fees totaling anywhere from 2 to 5% of the total purchase price plus tax. What a ripe opportunity for disruption. So think, if we remove those intermediaries from the exchange of value, will the impact be as profound? Nobody knows for sure. I think so. But here's what I do know for sure. Those intermediaries provide very important functions. To illustrate, let me ask you a question. So if you received an email from a stranger saying they will give you $1,000 for your smartphone, would you take it, put it in an envelope, and send it? I think it's a safe bet to say the answer is no. What about 2,000? Still no. But there are approximately 1 billion transactions happening between complete strangers on the internet every day on eBay. Now, why is that? That's because of PayPal. PayPal is a corporate intermediary, and that intermediary establishes trust. Intermediaries provide very important services. They establish trust. They verify the identities. They provide security. They prevent fraud. They do reconciliation, and they process the transactions. But they also bring with them some challenges. And those challenges include they're centralized, which makes them vulnerable to attack or failure. They're typically higher cost. They're slow. Change is very incremental, and they're not easily automated. So if we want to remove those intermediaries from the exchange of value, but retain the trust that's established, how do we do that? We do that with the distributed consensus model, which Marc Andreessen, a HPE board member, entrepreneur, co-author of Netscape, says is the most important invention since the internet itself. This is a mechanism where trust is established in distributed ledger networks. So we'll break it down. We'll first talk about the distributed part, and then we'll talk about the consensus part. So the fundamental design for every blockchain network is a decentralized peer-to-peer network. The fundamental advantage of this is that any particular node can fall off the network, and the network still runs. Now, for every blockchain network, each node has its own ledger. And those ledgers contain exactly the same information as every other ledger in exactly the same chronological order. So let's take a look at the ledger for A. Is there a transaction in there that says A paid B 11 euros? Yes. So is that the truth? Well, in today's world, the answer is only one ledger matters. That would be the ledger of your bank. So if you have a dispute with a vendor, did you pay the bill? All you have to do is go onto your bank's ledger and say, yep, it shows I paid. End of discussion. But in the distributed consensus model, one ledger is not enough. All the ledgers have to agree. So do all the ledgers show that A paid B 11 euros? Yes, they do. Is it in the same chronological order? Yes, it is. So can I trust the identities of the parties between the transactions? And can I trust that the transactions have not been hacked or modified in any way? The answer is yes, because each, in the distributed consensus model, all the ledgers agree. Each transaction has digital signatures, and the transactions are cryptographically hashed. So in the distributed consensus model, because all the ledgers agree, the answer is yes. A paid B 11. So this is the fundamental design for all distributed ledger systems. So now let's go back to my question. How do you pay for a taxi? Well, as I said before, in today's model, it's 16 steps, 6+ parties, 7 days. But if their taxi driver and the passenger are using a cryptocurrency like Bitcoin, it's a single step, 2 parties, and 1 hour. So a passenger paying a taxi driver is a perfect example of what we at HPE call blockchain 1.0, people transacting with people. So when the blockchain team was devising our strategy, it helped us to come up with a construction here to try to understand the evolution of blockchain use cases. So blockchain 1.0 we coined as people transacting with people. So this is a focus on cryptocurrencies like Bitcoin, fully decentralized networks, transactions happening between anonymous users over heterogeneous infrastructure. Blockchain 2.0 is different. Blockchain 2.0 are enterprises transacting with enterprises. These are typically private permission networks that have specific functional and non-functional requirements. And in blockchain 2.0, privacy between transactions is very important. Blockchain 3.0 is very exciting. It's the intersection of blockchain, the Internet of Things, big data, AI, and the intelligent edge. So to give you an example of blockchain 2.0, let me show you a use case from the insurance industry. So suppose you're an insurance company, an auto insurance company, and then you get a claim in for an expensive auto repair. Is it fraud? It's estimated 5 to 10% of all claims coming into an insurance company are fraudulent. Is it a mistake? Does the driver's history validate this claim? And what do you know about the repair shop? Well, in today's model, it's very difficult to answer those questions because the data is scattered across all these different entities in their own silos. There's interoperability issues between them. The whole process is inefficient and expensive, which brings a very poor and slow user experience to all involved, and there are privacy issues. So how can blockchain help? So the first thing we do is start with the same decentralized peer-to-peer network. But in this case, the nodes are each one of the members of this ecosystem. And what you'll also notice here is that each one of these members of this ecosystem still maintain their own database. What gets put on the ledger, instead of financial transactions like the example I showed you previously, are pointers back to those records in their local database. So remember, all those ledgers contain exactly the same information. So let's take a look at the insurance company's ledger. So what do we see here? A to B. So the driver and the police department. So the police department entered the accident in their local database. They put a pointer of that record into the distributed ledger. It was digitally signed, it was cryptographically hashed, and it was synced to all the other ledgers. So there you go, there's step one. The next record, A to C, the car was towed to the repair shop. The repair shop received the car, put an entry in their local database, and a pointer was put onto the distributed ledger, and then it was synced to all involved. C to D, the repair estimate was sent to the insurance company. So there you go. The benefits there are clear. You now have a complete accident claim history that's secure and available online. The identities are verified because we're on the same distributed network. Access is still controlled by digital signatures and protected with cryptographic hashing. Because of this information, there's lower risk, there's reduced errors, and there's greater fraud detection. And this also makes history available for data mining and risk analysis. Overall, a better experience, lower rates, faster payouts. So this is an example of blockchain 2.0. Enterprises transacting with enterprises, and that's HPE's focus. At Hewlett-Packard Enterprise, we focus on enterprise blockchain. Enterprises from all industries are investigating blockchain, but enterprises have very unique requirements. Remember, blockchain 1.0, which is people transacting with people, they're anonymous actors. You just pull out your phone, you can get an account, and you can exchange bitcoins. They're conducting transactions in total transparency. Enterprises are different. They require privacy. Transactions are happening between known actors. And they live in a world of geographies, of regulation, and jurisdictions. So the functional requirements for enterprises and blockchain are unique, but the non-functional requirements, non-functional requirements should be very familiar to all of us. They require speed, resiliency, scalability, security, manageability, and control. Running a blockchain system in an enterprise, those non-functional requirements are no different than if they were running any other mission-critical system. So to help our customers meet those requirements of blockchain 2.0, we developed our blockchain strategy, and it focuses on enabling enterprise-grade blockchain workloads. And we do that in 3 ways. We do that with differentiated hybrid infrastructure, so helping our customer develop the right mix of on-prem, private and public cloud, and technology and architectures that run blockchain workloads in unique ways. Consumption models, end-to-end delivery to help our customers with their business models, along with our partners to help them say, well, how does my business model need to be modified or changed to take advantage of blockchain? And once that business model is defined, working with our Pointnext Services organization, how do we translate that business model into a technology architecture? And then finally, strategic partnerships. There are multiple platform providers out there. The software that allows all those ledgers to exist and replicate, customers are using a variety of those. We partner with those providers to be able to provide many options to our customers. One example of that is our partnership with R3, and that's the first example I'd like to talk to you about today. Along with R3, R3 is a fintech who created a distributed ledger platform called Corda. Along with R3, we created what we call the the Mission Critical Distributed Ledger Technology Platform, the Mission Critical DLT for short. And it's an integration of R3 Corda and the HPE Nonstop, which is designed specifically for the enterprise. And it's available on-premise for production deployments or as a service for pilots and POCs. So Corda is special. Corda was designed to meet the functional requirements of regulated financial services enterprises. It has the ability to run smart contracts. It has the ability to maintain transaction privacy between different parties. And you know that your data is secure and running properly within a distributed ledger model. That's R3 Corda. The HPE Nonstop is the system today that runs 2 out of every 3 credit card transactions. It is the industry standard for reliability, security, resiliency. So it brings high levels of resiliency. We've created a SQL database to allow your blockchain transactions to be accessible to your legacy systems. And we integrated high levels of fault tolerance. So the Mission Critical DLT is a unique offering. There is no other place out there in the blockchain ecosystem to be able to take a system that will meet your functional requirements and meet those traditional non-functional requirements running blockchain workloads. We also announced blockchain services from our Pointnext Services organization. So Pointnext, our services organization, created the Blockchain Discovery Workshop. So we sit with our customers and over a one-day period help them define their blockchain journeys, understand what their competitors are doing in blockchain, and help them identify use cases for them to begin the development and experimentation in blockchain. And along with our hackathon, over a 3-day period, our developers and our customers' developers can sit down, develop an application, be it on Ethereum, on Azure, be it SIA, be it R3 Corda, regardless of the platform, our Pointnext organization, through the hackathon, can help our customers develop a blockchain proof of concept so they can begin learning what blockchain means to them. We're also working with a number of other platform providers because our customers require choice. Recently, HPE announced that we've joined the Enterprise Ethereum Alliance. So remember, when I showed that distributed network platform and those ledgers, there are a number of platforms, software applications, protocols that manage those ledgers and keep them in sync. Last time I looked at Gartner, there was about 80 of them. The blockchain ecosystem is dominated by startups. But when we talked to our customers, there really were 3 that stood out. One was R3 Corda, so we partnered with them. The other one is Ethereum. Ethereum is another smart contract distributed ledger platform made for blockchain workloads. And there isn't a company like R3 that manages Ethereum. Ethereum is developed and evangelized by an organization called the Enterprise Ethereum Alliance. And HPE is a proud member of the Enterprise Ethereum Alliance. We're also continuing our work with Corda to come up with new ways to extend our relationship. Another one of the popular distributed ledger platforms is Hyperledger. We're talking to them, and of course, our partner of over 30 years, Microsoft Azure Stack. But then we started to think, what about blockchain 3.0? Remember, things talking to everything. We said, you know what? Let's talk to Aruba, our Edgeline and Moonshot organizations, Intel for SGX for added security and big data. And let's see if we can create differentiated architectures that enable blockchain workloads that work on the edge. This brings us to what's exciting about blockchain 3.0, because things transacting with things all revolves around data. The edge is about data, and data is where the business outcomes come from. So let me give you a really cool example of something we're thinking about for blockchain 3.0. So think about an airline, right? One jet airliner generates about $100 million a year. Its lifespan is over 30 to 50 years. It'll have 3 to 5 owners over its, 2 to 3 owners over its lifespan. On any day, 10 to 15 of those airliners are on the ground for unplanned maintenance. So the objective of of owning an airline is to keep it flying. To keep it flying, it needs to be in good working order. And to keep it in good working order, every one of its parts need to be in good working order. And with an airliner, you have a lot of parts. In fact, you can think of an airliner as 1 million parts flying in formation. And every time one of those airliners lands, it offloads 2 to 3 terabytes of data. And at any one time, on average, there's 24,000 jets flying. So how do you keep track of, at any moment, of all those parts, the health of those parts, who created it, where it was installed, and how it's operating? That's a good question. What you do is you give each one of those million parts its own ledger. Now, you're not storing financial information, you're storing historical information, which is another excellent use case for blockchain. You have a record. You have who created that part, where it was shipped, who installed it, and every time you have the quality review data, what is the status of that part, and then eventually when that part was replaced. And then what do you do with those ledgers? You go back to the same decentralized peer-to-peer network, and you have an ecosystem of all the different entities that care about the health of that jet. You have the manufacturers. You have the suppliers, you have the airlines, airports, maintenance, and regulators. And what you have, since all these are synchronized now, and each one of those million parts has its own ledger, you now have what we call a digital twin. You have a digital representation of those million parts flying in formation. It's really cool. This digital twin concept is applicable here in this example. You can have a digital twin of a warehouse. You can have a digital twin of a number of complex systems. Now, there are a lot of challenges with this. The blockchain technology is not designed today to have terabytes and terabytes of data and these ledgers syncing all across. You need intelligence on the edge to handle this data, to process this data, to do AI on it and decide which data needs to be put in the blockchain and which numbers need to remain off the chain. It also requires competitors in these ecosystems to work together, and that's not a technology issue. That is obviously an industry and cultural issue, because many of the people in this enterprise in this ecosystem, they're not used to working together. But if they can work together, the benefits are in the hundreds of millions of dollars. It's estimated that with a digital twin, airlines can earn hundreds of billions of additional revenue, over 200 additional planes in the air. Right now, airlines have extra jets in reserve just for this unplanned maintenance. Higher asset utilization, and billions of dollars of savings due to greater efficiency, greater safety, greater reliability. This is blockchain 3.0. It integrates the intelligent edge, big data, AI. It's very exciting, and the Internet of Things. So I must say, This is a very, very exciting time to be in technology. It reminds me very much of what it was like in those early 90s when we were trying to figure out, what do we do with this new thing called email? We are entering the age of blockchain. Just like in 1991 with the dawning of the internet, blockchain will disrupt the exchange of value. And many enterprises from all industries are investing a lot of time and energy and resources in figuring out what blockchain means to them. Gartner estimates by 2025 the total business value generated by blockchain will be over $176 billion. So we at HPE are committed to bringing our expertise in blockchain, hybrid infrastructure, the Internet of Things, and the intelligent edge together to help our customers meet the challenges they face as they work to innovate and help their enterprises grow and thrive. Thank you very much.